Dear friends, today we are performing the experiment to find out the resistance per unit length of the given wire. Now the apparatus and material required in this experiment. First, that is the wire mounted on the board as you see, for which you want to find the unit resistance per unit length. Then the regulated power supply with output voltage 0 to 3 volt. Sometimes they can give you the dry cells of 1.5 volt, and if we join this type of two cells in series, we will get DC output of 3 volt. Then the DC milliammeter with range 0 to 500 milliampere. The DC voltmeter with range of 0 to 3 volt as you see. Then some wires to prepare the circuit. Now draw the circuit on your paper as shown in the figure. Now before connecting the meters in the circuit, check this thing, the pointer of the meter that should be perfectly coincided with 0. Now if it is not coincided, then by moving this screw given here, you can adjust it exactly at 0. In voltmeter you can see the pointer is perfectly coinciding with 0, but in milliammeter it is not coinciding with 0. So now here by rotating this particular screw, we can exactly adjust it at 0. Now for any DC circuit, the positive negative terminals are very important. So for the regulated power supply or given any meter, red terminals are positive terminals and black terminals are negative terminals. Now prepare the circuit as you see here. First connect the positive terminal of the regulated power supply with positive terminal of milliammeter. Then negative terminal of the milliammeter to the end of wire. Then from other end of the wire, the negative terminal of the power supply. Then connect voltmeter parallel to the wire, negative terminal of the voltmeter, that is with negative terminal of the power supply, and positive terminal, that is at positive through milliammeter. Now plug in the power supply and then switch on it. Now by rotating this particular knob, you can change the voltage across the wire and you can measure it from voltmeter. Now you have to take the observations for different voltages applied across the wire, and corresponding to that we have to take the measurements of the current flowing through it from milliammeter. Now in voltmeter between 0 to 0.5 there are 10 divisions. It implies that one division stands for 0.05 volt. That is the least count of your voltmeter. In milliammeter, between 0 to 100, there are 10 divisions, means each division stands for 10 milliampere. So least count of milliammeter, that is 10 milliampere. Now adjust the pointer of the voltmeter at 0.25 volt and now measure the current flowing through the wire from milliammeter as you see here. Now take the measurement of the different currents for the different potential differences applied across wire, like 0.5 volt, 0.75 volt, 1 volt, 1.25 volt and 1.5 volt. Now observations. range of ammeter, that is 0 milliampere to 500 milliampere, and on the scale between 0 to 100 milliampere there are 10 divisions, means one division stands for 10 milliampere, means least count of ammeter, that is 10 milliampere. Range of voltmeter, that is 0 volt to 3 volt, and on the dial of the voltmeter between 0 to 0.5 volt there are 10 divisions, means each division stands for 0.05 volt, means least count of voltmeter, that is 0.05 volt. Least count of the meter scale, that is 0.01 meter, and length of the given wire, that is 1 meter. Now for different values of potential differences across the wire, like 0.25 volt, 0.5 volt, 0.75 volt, 1 volt, 1.25 volt, and 1.5 volt. Measure the value of current flowing through the wire and note down as you see. And then convert this current, which one is measured in milliampere, to ampere by multiplying it with 10 raised to minus 3. And now calculate the resistance of the wire using this equation, R equal to V by I, for each observation of voltage and current. So you will get 6 values for the resistances here, and then take average of it. Now draw the graph of current I and voltage V, and your graph will be a straight line graph. Now for that, find out the slope. So slope of the graph, that is AB, that is delta I, upon BC, that is delta V. So if we take the reciprocal of the slope, then that will give you the resistance of the wire. So we can write here resistance of the wire R, that is 1 upon slope, that is BC upon AB. Actually that is delta V by delta I. Now resistance per unit length of the given wire, that is R by L. R, that is the resistance of the wire which we calculated, and L, that is the total length of the wire. In our case it is 1 meter, but in your experiment whatever is the length given to you for the wire, that you have to use here. Now calculation of error. So equation, that is delta R by R equal to delta V by V plus delta I upon I. So we can write delta R, that is equal to R into delta V by V plus delta I by I. Now here R, that we have to take this calculated value here, and delta V, that is the least count of the voltmeter, that is 0.05, and delta I, that is 10 milliampere, so that is 0.01 ampere, and value of voltage, that we have to take average of all the voltage taken here and take the average of the current measured in the observation table, and then after substituting those values of V and I here, calculate delta R. Now here from the graph we can observe this thing, the potential differences across the giving wire varies linearly with the current. And now write down here the resistance per unit length of the wire with error, that much ohm per meter.